Good morning, everyone. I'm Phương Lý Phạm. Welcome back to the course Food Waste Management. We will continue the study unit with the second lesson of the first module, Circular Economy's Principle in Food System. This lesson is about strategy for food waste prevention, reduction, and valorization. We will discuss the food waste hierarchy in detail and applicable strategy for each level of food supply chain. So, food waste is a big problem. It represents huge loss of land, water, energy, and labor, and also it contributes to greenhouse gas emission. In the meantime, many people still remain in food insecurity. Reducing food waste is therefore essential for environmental, social, and economic sustainability. The food waste hierarchy shows us the practice of prevention and minimization by prioritizing prevention, redistribution, animal feed, valorization, recycling, energy recovery, and finally disposal as the least preferred option. The top priority of food waste hierarchy is prevention, which aim to stop food waste from being generated by optimizing process and reducing inefficiency across the food supply chain. The prevention strategy include improve agricultural practice through better crop planning, precision farming, and optimized harvesting. Innovation in post-harvest technology like controlled atmosphere storage and advanced temperature humidity control. Manufacturing efficiency can be achieved through the tools like Lean Six Sigma, improved forecasting, and strict quality control. The use of innovative packaging like modified atmosphere packaging, active coating, and portion-based format can help the food waste prevention. Policy measures and economic incentives include grant subsidies, tax benefits, and national reduction targets. Supply chain optimization through better cold chain management, real-time monitoring, and improved logistics. And consumer awareness and behavioral change are always very important. It includes education on storage, portioning, and labor understanding. When surplus food cannot be prevented, it can be turned to redistribution that keeps safe edible food within the human food chain and support food security. In this way, the food still keep its value because it still aim for human consumption. Some practice in redistribution can be food donation network like food bank, charity, and digital platform that connect surplus food from producers and retailers to people in need. Community-based solutions like community fridge, solidarity market, and gleaning program can recover edible surplus and distribute it locally. Logistic and cold chain management, refrigerated transport, and efficient distribution ensure safe delivery of donated food. And finally, the barrier of redistribution can be overcome with clear guideline, liability protection, standardized procedure, and tax incentive. When food is no longer suitable for human consumption but still somehow safe, it can be turned to animal feed. This approach can reduce reliance on resource-intensive conventional feed. The byproduct of waste like fruit peels, spent green, and vegetable residue can replace traditional feed, lowering environmental impact. There are also technological improvements in feed processing. For example, the process like dehydration or drying, extrusion, and fermentation can improve the safety, shelf life, and nutrition, and enhance digestibility. The next level of the hierarchy is industrial use. The valorization convert unavoidable waste or byproduct into bio-based chemical material and ingredients, supporting a circular bioeconomy. Through the valorization, we can obtain the bioactive compound through extraction. The compound, for example, like antioxidant, fiber, pigment, and polyphenols. We can obtain through fermentation the enzyme, organic acid, and fermentation products. We can also obtain the biopolymer and packaging material like starch-based plastic, cellulose film, or PLA, which is an abbreviation of polylactic acid. The biotechnology and novel material include the waste-derived biosurfactant, biofertilizer, and mycelium-based material. When on the previous option are not feasible, the food waste can be turned to recycling and nutrients recovery. In this case, the nutrients is no longer for human consumption. Recycling and nutrients recovery turn organic material to natural system, closing the nutrients loop and reducing reliance on synthetic inputs. Some practices of this level include composting, which convert organic waste into nutrient-rich soil amendment. Vermicomposting, this is where the earthworm digest and break down organic matter into nutrient-rich vermicompost. Biofertilizer production, in other words, is anaerobic digestion that produce both biogas and digestate that can be refined into fertilizer. And finally, the recovery of water and minor nutrients through the advanced filtration, ion exchange, and electrodialysis. With this technology, we can recover clean water and nutrients like nitrogen and phosphorus. A lower level of the hierarchy is energy recovery. This approach converts residual food waste into useful energy sources like biogas, heat, electricity, and biofuel when higher value use are not possible. An option is anaerobic digestion. In this approach, microorganisms break down waste in the absence of oxygen, producing biogas and digest it. The biogas that we obtain can generate heat, electricity, or be upgraded to biomethane. The digestate that we have just mentioned in the previous level become a fertilizer after separation and processing. In biofuel production, the starchy waste can be converted into ethanol, while fermentation and photofermentation can generate hydrogen. Lipid-rich waste become biodiesel through transesterification. The pyrolysis or gasification can produce syngas for bio-oil or for further refinement. And that we have thermal conversion. The process like pyrolysis, gasification, and incineration with energy recovery break down the waste at high temperature. In particular, pyrolysis generates biochar, and gasification generates syngas for fuel. The last level and also the lowest level of the hierarchy is disposal. This is the least desired option because it destroys entirely the resource values and it causes significant environment impact. The two options of this level is landfill and incineration. In landfills, decomposing organic waste under the anaerobic condition release methane and produce pollutant-rich leaches. The innovative technology can reduce, but it cannot eliminate the environmental risk. So, for this reason, many regions restrict the landfilling of organic waste. The other option is incineration without any energy recovery. Uh, with this practice, we can reduce the waste volume, but the potential energy and resource are wasted. It also generates air pollutant, so it is discouraged increasingly due to environmental impact and public concern. Thank you for watching. With this lesson, we have just concluded the first module. In the next lesson, we will start the second module of the study unit, which is about environmental impact assessment and management. See you next time.